Okay, I think we are live. So, hello everyone. My name is Rubitel. I go by Blue Hen Coding on TikTok, and welcome to, well, this is now lesson 7 of our little course, Learn Programming with Python. Um, I did take sort of a brief hiatus for a couple days. I think the last stream was on the 30th of June, but we're back, and hopefully this time it's a little bit more consistent with the days I choose to stream on. Because last time I was just like doing random days just to like fill my time. But what I want to do for the month of July is I want to do like, all the weekends, like Saturday and Sunday, because I feel like that's more convenient for most people. And also just like makes more sense to have streams on those days. So how is everyone else doing? How are you guys doing? What's going on? And I'll give it a couple more minutes for everyone else to join if they're a little late or whatever. And then we can go ahead and get started. Hello, Luke. How are you? Awesome. Awesome. That's good to hear. 1 through 6. So yeah, welcome to your first live lesson. Hopefully this one it's going to be a good one. I think this is going to be a good live lesson that we're going to have tonight. Okay. I'll give it another more minute and then we're going to go ahead and get started. Hey Maria, how are you doing? All right. Yeah. So let's go ahead and actually get started. So this is lesson 7. We're on lesson 7 right now. Lesson 6 and lesson 4 were recorded lessons, so I wasn't there to actually like, answer any questions and stuff like that. So if you do have questions from those 2 lessons in particular, feel free to ask them right here. We can touch upon them. But let's start with a review of lesson 6. And this review is going to be a little bit longer because, again, it's been a while since I posted a video. And again, lesson 6 itself was a recorded video. So lesson 6 mainly talked about, actually, let me come to the lesson 6 repo here. Lesson 6 focused on the idea of these things called lists. And what a list is, it's sort of like a data container. So we called it a data container. So what does this mean? Well, so far we've worked with strings, integers, floats, booleans, right? And we know that those things are called data types. So from the name data container, we can infer that a list is some sort of way to contain different data types or multiple items of the same data type. So the first thing we did is we showed how to, or actually we explored sort of the need for a data container. And I did that through the analogy of a classroom, right? So say you're a teacher and you have a bunch of students that you need to manage, right? How do we sort of contain all of that, right? Well, within what we know, there's no sort of way to do that. But what we could do is we could have a bunch of variables, right? Student 1 is equal to John, right? Student 2 is equal to Ed. Student 3 is equal to Steve. Sure, this looks fine for, a small group of students. But what if we have 40 or so kids or 50 kids or 60 kids, it doesn't really make much sense to go student 1, student 2, student 3 all the way to student 60. And again, that would take up so much space and be so hard to work with. So let's explore how a data container can help us with that. So the first step in creating a list is to give it a name. So let's think about the situation we're working with here. We're working with a group of students. It's a teacher, so we'll just go ahead and call this list class roster, right? That's the name. It's just like setting a variable. And I say that's equal to, and then my list is enclosed within these brackets. So this right here is an empty list, right? There's nothing within this sort of brackets. There's nothing that is being contained by our list. So I've created an empty list here. Let me get rid of this actually. I've created an empty list called class roster. All right. So now let me go ahead and add some things to it, right? I'm going to add a bunch of names of students. So I'm going to have Steve. We had Ed, Stacy, Varun. This looks a little bit nicer, right? And it makes a little bit more sense. We don't have to have a variable name for every student, but we have all the students' names within this sort of list called class roster. And another way you can look at a list is sort of like as a grocery list. So think you're going to the the grocery store, and you have your little grocery list with you. On that grocery list, you have milk, cereal, vegetables, right? These are all different things. Think of different data types, but where they're all contained within sort of the scope of this entire grocery list. And that's sort of another way you can look at why a list exists and why it might be useful for you when you're programming. So is everyone okay with lists, data containers, that sort of idea of being able to contain, because these are all strings right here, right? These are all strings, and you can tell that there's 4 independent strings, right? And they're separated by these commas right here. All right, I'm seeing it all good. So let's move on with the review. So we'll say this is creating a list. Cool. The next thing I want to touch upon is printing a list. And this is pretty straightforward, right? Printing a list. We just have our normal print statement, right? And what do we want to print? We want to print this entire list right here. Well, how can I do that? Well, I know it's assigned to the variable name class roster. So I can just go ahead and say print class roster. We open up our console, and you can see it works perfectly. But you'll see that we're printing out the entire list right here. It looks exactly the same. What if I wanted to print specific items? What do I mean by that? What if I only wanted to print Steve's name or Ed's name or Stacy's name or Varun? I don't want to print all 4. I just want to print a specific one, or I want to pull a specific one out of the list. Well, with that, we use something called indices, or indexing rather. So let me go ahead and actually show you how this works. And I'm actually going to comment this out so it doesn't clog up our console. So I want to print a specific item. Let's say for this example, I want to print Steve. So we already know you can have your print statement, right? And I'm pulling from this class roster list. So I know I'm going to have to reference that name. So class roster. Cool. Well, we know if we do this, we'll print out the entire list. So we're working our way towards printing out just Steve. So from here, where do we go? Now, this is the point where we use the index of the item that we want to print. So let's sidetrack a little bit here, and let's talk about what an index is. So think of an index as sort of like an address, right? You have your home, it has its own associated address. If someone wants to find you, right, if they want to come to your home, you give them that address and then they're able to locate you. So let's say this list right here, right? It has 4 different items. Each of these items has their own index, their own sort of address. So let me actually come here, and I'm going to put the indexes, and you'll be able to see Steve has an index of 0, Ed has an index of 1, Stacy has an index of 2, and Varun has an index of 3. Okay, so what's going on here? So as I said, each of these items has their own address. So think of this 0, right, index, a 0 index pointing to the name Steve. Whenever I give it the index 1, it points to the name Ed. So now let me just sort of return to what we were doing earlier. We want to print out Steve's name. So in order to do that, I then open up my brackets. So this might look a little weird, right? We're going to have these brackets right here after we say the list name. And then we're just going to put the index of the item that we want to pull. So again, I want to pull Steve, and Steve has an index of 0. I'm going to run this, and you'll see in my console, I get Steve printed out. So this might seem kind of weird. Like, how am I able to just pull items like this? And let me do another example. Let's say I wanted to print just Varun instead of Steve. We know that Varun has an index of 3. So I'm going to come down here. I have my class roster, so I know I'm pointing to this list. And then in my brackets, I'm going to put 3. I run this, it prints out Varun. So how do we know what item has what index, right? How am I able to just know that? So the index is actually given based off of the item's position in the list. So Steve is the first item, right? It's the first thing in this list and has an index of 0. Ed is the second item in my list and has an index of 1. Stacy is my third item in my index, but has an index, is the third item in my list and has an index of 2. Varun is the fourth item in my list and has an index of 3. So from that, we can sort of pull the pattern that the index, right, the index is sort of equal to the item's position in the list minus 1. Let's try to use this formula and see how that works here. So Steve, right, we want to find its index. Where is Steve? Where is it in the list? Well, it's the first item, right? It's number 1. 1 minus 1, 0. And that gives me that index of 0. And again, you don't really need that formula. That's just sort of a way I wanted you guys to be able to visualize what's going on with this index. So, yeah, and that actually, yeah, that talks about the idea of how Python is a 0 index language. So you know how we start counting, right? This is the first item, the second item, the third item, the fourth item. Python actually looks at this as this is the 0th item, right? It starts counting from 0, if that makes sense. So that might be another way to help you understand how an index works. So are we all okay with indexes right now? Because that's sort of like the most confusing part of what we're going to talk about in this review. Awesome. I'm seeing yes. Okay. Then let's keep going. Let me get rid of this. Move this up here. Print specific items, indexing. Okay. There is another way to pull items, but instead of using their index, you use their negative index. So now let me explain this. Print specific items, negative indexing. Negative indexing. Cool. What do we mean by negative indexing? Well, negative indexing is sort of just working backwards, right? With indexing, we're working from the front, going back. With negative indexing, we're going to start at the end of our list, right? All the way out here, right? Let's just pretend that's the end of our list. And then we're going to work back. So let me actually go through an example, and then we'll explain it. Again, pretty straightforward and pretty similar to how we normally do our indexing, right? You have your print, you have your name of the list, and then you have those brackets. All that really changes is the number that's going within those brackets. So for this example, I want to print Varun, right? This is what I want to print. And if we were doing this normally, we would have this, and we put 0, 1, 2, 3. So yeah, we would put 3 in our little brackets. But how can we also do this with negative indexing? How can we get the same result? So just imagine there's some space, there's sort of a starting line right here at the end of my list, right? And every time I jump backwards one, I'm going to add something. So let me go through it. Let me sort of explain what I'm doing. So I'm starting back here, and I want to get to Varun, right? Starting here, I go 1, and then I'm here at Varun. So I've jumped 1 backwards. So my negative index, I'm going to put -1. If I run that, you see they get the same result. This and this are equivalent to the same thing. And let me go through another example. Let me comment that out. Let's say I want to print ed, right? Let's clear out these brackets. I'm going to start at my starting point, right? And we're going to count how many times I have to jump backwards. I'm going to jump back 1, 2, 3. So I've jumped backwards 3 times to get to ed. So in my sort of brackets, I'm going to put -3. I've jumped backwards, so that's the negative, backwards 3 times, and that's where the 3 comes from. And if I run this, I get ed. So negative indexing and indexing, we've covered that. Now let's talk about how we can sort of explore this. Let's explore indexing and negative indexing, and let's sort of use what we know with for loops to do this. So I'm going to clear this out, and we're going to call this section exploring indices with for loops. So let's go ahead and create our standard for loop. We all know how to do this. For I in range, and I'll leave the range blank for now. We're going to print I. Cool. So I want to use this for loop to explore the different indices of my list, right? And we know the indices of this list in particular, they are 0, 1, 2, 3, right? So we're starting at 0, and my indices go all the way to 3. How can we mimic this with our range? Well, the only thing we really have to specify is our stop, right? We don't have to specify a start or a step because we know that with our for loops, it automatically starts at 0. That's good. It automatically increments by 1. So it's going to 0, 1, 2. So that's good. So then all we have to do is tell it when to stop. And if you remember, with our for loops, our stopping point is all the way up to, but not including that number. So I want to go all the way up to 4. I'm going to go for I in range 4. Why? Because that'll give me, when I run it, 0, 1, 2, 3. Just like these indices right here, right? Because if you remember, 4, it goes all the way up to, but not including 4. So that means we'll get 0, 1, 2, 3. Cool. So we have these numbers, right? We're printing out I. Now let's use this to print out these specific items. I'm actually going to use my comma separation. If you remember this from our first lesson, how we have our different print statements. We're going to print that number, and then we're going to print what that number sort of points to in the list. We're going to have our class roster in our brackets, and then we have that I. This. So you see that Steve is 0, Ed is 1, Stacy is 2, Varun is 3. So what is this doing? So this for loop is giving me all the values from 0 up until 4. So 0, 1, 2, 3, right? 0, 1, 2, 3. And then I'm using the numbers that the for loop gives me as indices to pull specific items from my list. And I just print them both out so we can visualize them like so. So that's our exploration of indices using for loops. So everyone okay with that? Because again, indices are sort of like the more confusing thing when it comes to lists and stuff like that. Can we do another example? Yeah. So do you want to do another example with indices or another example with how I used this for loop right here? Okay. So let's create another example. And I'm just going to comment this out. Let's create some extra space down here. Okay, perfect. Instead of using a student roster, let's create something different, like a grocery list, like I had mentioned earlier. So grocery list, What do you usually have in a grocery list? Well, you have fruits, might have ice cream, might have milk, might have cereal, you might have yogurt. I think that's how you spell it. I think that's enough. So we have one, two, three, four, 5 items in our grocery list. So let's talk about our indices quickly. So we know, let's do the comment thing. We know our fruits. It's the first item in my list. So therefore the index will be 0. Ice cream will have an index of 1. Milk will have an index of 2. Cereal will have an index of 3. And yogurt will have an index of 4. How am I able to do this? Well, think when you're counting, you start at 1, right? 1, 2, 3, 4, 5. That's how I was able to tell there was 5 items in this list. Python, on the other hand, works a little bit differently. It doesn't start at 1, it actually starts at 0. So when Python counts this list right here, it says 0, 1, 2, 3, 4. So it's just how we count, but it's just starting one number before, starting at 0. And that's how these indices are formed. What I wanted to do with the for loop is use it to sort of show you guys how you have these indices, and then these indices can be used to pull specific values, right? So I'm going to have my for I in range. We know with our range, we have to give it a start, a stop, and a step, right? So where are we starting from? We want to print out, I want to print 0, 1, 2, 3, 4. Those are the numbers I want to print out. Well, I'm starting at 0, right? I'm stopping at 4. So what do I give this? I give it 5. Why? Because with my range function, I have to specify all the numbers up to, but not including. So I'm basically getting all the numbers from 0 up to, but not including 5. So it actually ends at 4. And then my step, well, I'm going 0, 1, 2, 3, 4. I'm adding by 1 every time. So my step is 1. And I made it explicit this time. Otherwise, you could just leave these two out, right? Because start is 0 by default and step is 1 by default. But we'll just leave it there so it's easier to understand. Oops. So then we're going to print out these values, right? And what do we get? 0, 1, 2, 3, 4. Cool. It's just printing out our normal loop, right? This is simple stuff. We've done this before. But you'll note that these items sort of pertain to the indices right here, right? So how can I use the sort of numbers that my for loop is generating to print out specific items from the grocery list, right? So basically, I'm going to use this I value, which is different every time in this loop, and I'm going to show you how that pertains to specific items in the grocery list. So I'm going to print I, right? That's going to give me this number. And then I'm going to print grocery list. If I do this, right, I get 0. I'm printing out this full thing right here, right? So this is, again, this is pretty straightforward. I'm going to then put in my brackets, right, because this is how you usually do your indexing. And I'm going to put I in here. And now you see I get fruits, ice cream, milk, cereal, yogurt. So let's go through this. My for loop runs 5 times, right? The first time it runs, the I is 0, right? It is 0. So I'm able to pull fruits from my grocery list because since that I is equal to 0, this basically comes out to being like this, right? So it's saying, hey, Python, take the grocery list, right? So this thing right here, and give me the item that has an index of 0. Well, we already know that fruits has an index of 0. So that's why fruits gets printed out alongside this 0. Cool. And then our for loop runs the second time. And when it runs the second time, our I value isn't equal to 1. So this print statement becomes this, right? You see that matches up with this right here, and it's our second time running. Now Python is, I'm telling Python, hey, go back to that grocery list and give me the item that has an index of 1. And the item that has an index of 1 is ice cream. So that's how this gets printed out. And then it goes to 2. Grocery list, give me the item at the index of 2, and that's milk. And then so on, and it just goes on like that. Makes sense. Awesome. I'm glad I was able to clear that up. So that is our sort of exploration of indices with for loops. Actually, let me bring that example back. And now we're going to use this. Let me comment this out. It's getting kind of cluttered, so I'll be sure to clean that up in a while. We're going to use this to introduce something called the length function, len function. Let me clear this whole thing up. Let's just switch to this grocery list example. Cool. So we have this now. Everything's cleared up. We have our indices. I'll leave that there, actually. Now I want to talk about the len function. This is a new function that we're going to add to, how do I comment it? Well, commenting is you just add the hashtag, and you can just type whatever you want. You won't get any errors. Python just skips that. And commenting is just used for documentation so that when you read your code later on, you know what you're looking at and you don't get confused by whatever you wrote. So, len function. We're going to add this to our list of functions. So what functions do we know right now? We know our int function, our float function, our str function, our input function, our range function. Let's add one more to our sort of repository of functions. So this is our length. I think I spelled that right. Yeah. So you can probably assume that this length function, when given something, will tell you how long it is. Well, that's pretty helpful here with our grocery list. So I'm going to print actually, let's create a variable. We'll call it grocery list length. We're going to set that equal to the len of grocery list. So again, what am I doing here? Well, if you touch back to, I think it was lesson 5 or 4, one of those two, we talked about functions, right? So I have my length function, that's the name, len, and I'm passing it the argument of this entire list, right? So this function is going to run, and then it's going to return how long that list is. So then if I go ahead and I print grocery list length, what I hope to see? Well, I know this is 1, 2, 3, 4, 5 items long. So hopefully when I print this, it should say, oops, grocery list length not defined. Oh, I spelled it wrong. Dang. My bad, guys. Always check your variable names. If I run this now, I get 5. So what is this doing? I'm calling my length function. I'm saying, hey, length function, I'm giving you this grocery list right here. Can you just go ahead and tell me how long it is? The length function is going to say, okay, it's going to do all the computational things that it needs to do, and it's going to give me a value. It's going to return that value. That value, right, whatever the length function gives us, will then be saved to this grocery list length variable. And now when I reference that, it prints out 5. Actually, let me make this a little bit bigger so it's easier to see. So then it prints out 5. Awesome. So why did I introduce this? What is the point of having this? Well, let's backtrack to our for loops one more time. And I promise this is the last time we'll touch with for loops in this lesson. So for I in range, right, we're going to print I. So range. Let's say I wanted to print out 0, 1, 2, 3, 4, right? I want to do the same thing I did before, using my for loops to explore my indices. All I have to put here is 5, right? And if I print this out, you see we get 0. Let me comment this out. We get 0, 1, 2, 3, 4. And these are the indices right here. What if I have a list so big that I'm not able to sort of just count the values like I'm able to do right here, right? 1, 2, 3, 4, 5. Then wouldn't it be pretty handy to have that length function to tell me how long something actually is? So again, let's add that grocery list I thing, right? And we already know how this works. So I run this, we get, this is what we expect to get. But how can we use our length function with this? Well, we know that it's going to give us a value of 5 when we print out this grocery list length, right? This and this are equal to each other. So I actually say for I in range grocery list length, right? And I run this, I get the same exact thing. Why? Because Python is going to run this and it's going to give it the value of 5 because we know our grocery list is 5 items big. 1, 2, 3, 4, 5. So that means grocery list length will then be equal to the value of 5, right? So this is going to become 5 right here. So it's just like the same thing we had before. And what we can actually do is we can actually skip saving this length to a variable, and we can actually just copy this and put it in directly. But for I in range and the length of grocery list, I run this, works perfectly fine. So how does Python look at this, right? Python, as I said before, and I've said many times, it works in and then it goes out. So this is the whole thing that we need to figure out, right? I'm going to start at the innermost point, length grocery list. Okay, I know that's going to give me 5. And then range 5, well, that's something we already know what that does. So that's how our length function might be helpful. Say if you have a list that is so big that it doesn't make sense to, count all the items by hand, but you still want to do something like this with it. And that's how you can use a list like that. So does the length function and the for loop, the sort of how they're able to work in tandem, make sense with you guys? Oops. Awesome. Luke is giving me a yes, so let's keep moving on. And this review is going to be a little bit longer because, I wasn't here for the last lesson. Or sorry, I was here for the last lesson, but it was recorded. So I want to make sure I'm as thorough as possible. So, only a couple more things left to go over before we can move ahead with what I wanted to talk about today. Then we're going to go over something called sublisting. Sublisting. So with my indices, I talked about how I wanted to pull specific items from my list, right? I wanted to pull fruits, ice cream, milk, cereal, just specific items. What if I wanted to print, say, a group or pull rather a group of items, right? What if I had this entire list, but from this list, I wanted to pull fruits, milk, yogurt, or fruits, ice cream, milk, or milk, cereal, yogurt, like derive a sort of smaller list from this, this main grocery list. So that's where sublisting comes into play. So how do we sublist? Well, first, let's talk about the idea of indexing just one more time. How do I print out fruits? Well, we know it has an index of 0. Right? It's the first item. We have grocery list right here. And then in my brackets, I'm just going to put 0. If you run this, we get fruits. So we know that's sort of our base that we're going to work off of. With sublisting actually works very similar to our range function in the idea that you have to give it a start a stop, and a step. How can I mimic this sort of like our range function? So again, it's all going to be contained within this brackets. And you'll remember with our range function, I could separate my start, my stop, my step with commas, right? Well, with our bracket, we're actually going to use semicolons, or colons rather. So my start value is going to go here, my stop value is going to go here, and my step value is going to go here. This should look something similar to like a range function where you have your start, your stop, and your steps. You'll see they look kind of similar. So what do I want to do? I want to print fruits, ice cream, milk. I want to print these first 3 items in my list. Well, where am I starting from? Right? And you have to remember, this is all done with the indices. I'm starting from fruits, which has an index of 0. Straightforward. I'm going to skip ahead to step. How much am I stepping? Well, my index goes from 0 to 1 to 2. So it's increasing by 1, right? That's pretty straightforward. We'll leave that like that. Where am I stopping? Well, I said I wanted fruits, ice cream, milk. Milk has an index of 2, right? Remember, just like with our range function, it's up to but not including. So for my stop, I'm going to put 3, not 2, 3. So this is going to give me all the indices from here, here, up to here. And if I print that out, you'll see I get a tiny list. So our main list was 5 items big, right? Fruits, ice cream, milk, cereal, yogurt. And from that, I was able to pull fruits, ice cream, milk, the first 3 items using sublisting. Awesome. And just like with our range function, we have defaults. So there's not always a need to specify. So this 0, right? We always know that our range function starts at 0. So we can get rid of that. We always know that our start, or our step always is 1, so we get rid of that. And you see if I run this, we get the same exact thing. And you can also, simplify this even more. This last one right here, you don't need that. But for the sake of writing clean code, I encourage you guys to write them like this. Either make it explicit like this, or leave your colons there to show where defaults are being used. So that is very, very brief usage of sublisting. And actually, let me use it one more time. So we know this is going to print out fruits, ice cream, milk. Let's say I want to make a new example. We're going to print fruits, milk, yogurt. Fruits, milk, yogurt. So let's create our general structure. Get rid of that right there. Fruits, milk, yogurt. We're going to add our little placeholders, right? Our start, our stop, our step. I want to print fruits, milk, yogurt. Where am I starting from? Well, I'm starting from fruits. Fruits has an index of 0. Cool. Let me skip ahead to my step. Going fruits, then milk, then yogurt. So my index is going from 0 to 2 to 4. 0, 2, 4. So it's sort of adding by 2 every single time. So my step is 2. Now we talk about our stop. Well, 0, 2, 4. So I want to go up to 4. Right? So for my stop, I'm going to put 5. Up to, but not including. So it's going to give that 4 there. And if I run this, I should hope to see fruits, milk, yogurt as my new list. Awesome. And again, you can always save this to a variable. So we can call this smaller list. Right? Just like that. And then you can use that list to sublist or do whatever you want to with that. So that is sublisting. Does that make sense? Is everyone okay with that? Awesome. So we've gone over sublisting, we've gone over our length function, our for loops. Now we're going to go over changing values in a list, deleting values from a list, and adding values from a list. So those are the last three things we have to cover. Let me make this a little bit smaller. Let's clear this out. And I'm actually going to go ahead and get rid of these indices right here, so we don't have them to hold our hand for us. We have to be able to, be able to do those things mentally. Now we're going to talk about changing values in a list. So let's say I'm at the grocery store. I'm looking at my grocery list and I see this, right? And I'm thinking, well, I actually don't need more ice cream. I actually need water. I need bottled water. Okay. Bad example, but you get what I'm trying to do here. So what you want to do is you want to take your little pencil, right? You're going to scratch out ice cream and you're going to replace it with bottled water. So let's try to mimic that sort of real life thing within the scope of our code. So changing values in a list is pretty straightforward. So the first thing you have to do is you have to tell Python what list you're working with. Well, we're working with our grocery list right here. And I want to change ice cream to bottled water. Well, where is ice cream in my list? What is its index? Well, we know it's the second item, right? 1, 2. That means it has an index of 1. Because again, Python starts counting from 0. So 0, 1. So I'm going to say, hey, Python, take that grocery list, take the item at the index of 1, this right here, and then make it bottled water. So pretty straightforward. It's literally just taking that sort of space in that list, right? The space that has an index of 1, and you're going to make it bottled water now. So we're going to print our grocery list before we make that change. And then after we make that change, we're going to print our grocery list again, grocery list. We clear this, run it. So the first time I have our print statement is before we make the change. So we have fruits, ice cream, milk, cereal, yogurt, just like what it was when we first declared it. After we made the change, we print that list again. We have fruits, bottled water, milk, cereal, yogurt. So our ice cream is gone and has been replaced with bottled water. So pretty straightforward. And again, in plain English, it sort of reads like, take that grocery list, right? Take whatever value has an index of 1, so this right here, and then just make it bottled water. So that's how that sort of thing reads out in plain English. So that's how you change values in a list. Now we're going to look at deleting values in a list. Yeah, deleting values in a list. So again, I'm back at the grocery store. I'm making my purchases, and this is my first purchase. I've just bought the milk, right? I bought the milk. I can take my pencil. I can scratch that out because that's not something I need to worry about anymore. So I can sort of delete that from my grocery list. So how do we do this? So with this, we're going to use the del keyword. And again, it's just like how with Python you have def, elif. It's always short for like something else. So this is short for define. This is short for else if, right? It's sort of like that. So this del is short for delete. Okay. We're going to say, hey Python, delete my grocery list. And again, this is milk. Milk is the third item on my list. So that means it's an index of 2. All I got to do is that. And that's you delete a value from your list. So let's print the grocery list before. And then we're going to print our grocery list after. Cool. So fruits, ice cream, milk, cereal. And then we delete milk. So now it's fruits, ice cream, cereal, yogurt. So let's think about this in plain English. How does this read out? Python, do me a favor. Take that grocery list, right? Take whatever item has an index of 2 and just delete it. Get rid of it. So now my list has gone from having a length of 5 to a length of 4. And you might be wondering, does that change the indices? What do I mean by that? Well, we know that fruits right here, it'll always have an index of 0, right? Ice cream will have an index of 1 for both of these things. Milk had an index of 2, right? When we first started. But now that's not there. So does cereal still have its index of 3, or is it the index of 2? Well, the index is all based upon its position in a list, right? It doesn't get saved and like hard coded, if that makes sense. So right here, my serial index was 0, 1, 2, 3, right? It was 3. Now it's 0, 1, 2. So it's 2. So the index has changed. It's shifted down. So for the first two items, it doesn't really make a difference, right? Fruits and ice cream doesn't make a difference. But for everything that came after the milk, the index has shifted down, if that makes sense. Cool. So that's deleting values from a list. So does that make sense? Changing and deleting values. Because now we're going to talk about adding values, and that's where it's not as simple. I'm seeing a yes from Maria. Awesome. So let me go ahead and start talking about adding values to a list. Adding values to a list. Here our output there. Adding values to a list. So there's two ways to do this. So there's two ways to do this. We have dot append and we have dot insert. You might be thinking, wait, this is kind of weird. I mean, this append and insert part looks familiar, right? That looks like a function. Why is there a dot in front of it? We'll talk about that a little bit later on. These things are called methods, not functions, methods. And I'll have a brief touch upon it, but it's really not important right now. This is something that we'll talk about a little bit later when we're looking at object-oriented programming. So let's say I'm at my grocery store. I'm going through my list and I realize, oh shoot, I forgot to put chocolate on my list, right? Take my pencil, all the way at the bottom, I'm going to write chocolate. How do we mimic that? So I'm going to have my grocery list, and I'm going to use our dot append, right? So we're going to talk about dot insert a little bit later. We're going to use dot append. So dot append, and we're going to put chocolate. Okay, this looks kind of weird, right? Because usually when you have your function, you don't have this dot. Again, this is not a function. This is something called a method. Think of a method as a function that only works with specific things, like it's tied to a list. So this dot append only works with lists. It's a list specific thing. And again, we'll talk about it a little bit later on, but think of methods as functions that are specific to specific data types or specific things like a list. Again, don't worry about it too much. So what am I telling Python to do here? I'm going to say, hey, Python, take my grocery list and add chocolate to the end of it. Right? So that's what the dot append is used for, just adding something to the end of your list. So if I print out a grocery list, you'll see I get fruits, ice cream, milk, cereal, yogurt, chocolate. So it's been added to the end of my list. And let's say I wanted to add something else. I'm back at the grocery store and I realize, okay, I added chocolate. What else could I forget? Trying to think of like an item at the grocery store. We'll just say a or a Coke, right? A beverage, if you will. I run this again, right? We should hope to see have chocolate added. So that's our first dot append. And then we add our Coke and it gets added to the end of our list. So think of dot append as a way to just add stuff to the end of your list. So if there's no need for it to be in a specific location, dot append is the way to go. Then we're going to talk about dot insert. Let's clear this. So dot insert is sort of like dot append, right? You're adding something to the list, but you can choose where it goes. So dot append added all the way to the end, but dot insert allows you to specify where it goes. So again, back with that overused grocery list analogy. So grocery list dot insert, right? I'm at the grocery store. I'm trying to think of more items. Um, chips, right? Oh my God, I got a party tomorrow. I need to have chips. That is so important. I need to put it at the top of my list so I don't forget. Take my pencil, put it all the way at the top of my list, put chips. How do I do that? Well, I use my dot insert. And what dot insert takes is it takes an index and a value. So the value we're going to give it, we're going to tell it it's going to be chips, right? Our index is going to say, where do you want me, or Python, our index is used to tell Python where this chips is going to go. It's got to go to the top of my list. It's got to be the most important thing. It's the first item. Well, we know in Python that our first item always has an index of 0. So we're going to insert at an index of 0, or we're going to insert a value of chips. So how does this read in plain English? Python, take my grocery list, right, and make the first item in my grocery list chips. That's how that reads out. So now let's go ahead and print out grocery list. We'll print it out before and we'll print it out after we do our dot insert. So before we do our dot insert, we have our normal grocery list, right? Fruits, ice cream, milk, cereal, yogurt. Boom. It's going to put chips at my 0 index. So now you see this list looks a little bit different. Chips has been inserted at the index of 0. So now it's the first thing in my list. So there we go. That's dot insert, and that is dot append. So now let's take what we know, right? And we took what we knew actually in our last lesson, and we use it to build this class management system. And this might look a little, it's a big program. So let's go over what it does and how it sort of combines the various elements of what we've learned. So again, this was talked about and written in lesson 6. So if you want to see this getting programmed out, like coded out, you could check out lesson 6 on my Teach homepage. And I think that's right here. You just come right here, lesson 6. This is where we looked at it. So I'm just going to do a brief overview of what it does. So I wanted to create a class management system that allowed teachers to add names to a roster, remove names, and change names, right? So what I did was I started with this imaginary roster, right? Class roster, John, Susie, Janice, Nitish, right? It's just a list of 4 students. And then I created a while loop, right? So this function is, this program is going to run over and over and over and keep giving my teacher options. It's going to ask them, what would you like to do? So the options that the teacher had is to either quit the program, right? To leave. They could add a name to the student, to the roster. They could print out the roster. They could remove a student from the roster. They could change a student's name in the roster. So those are the different options that the teachers had with this code. So what it does is it's a while true loop. So it's going to keep running and it's going to ask them, what operation would you like to use? Queue, quit, add, remove, change, or print. If the teacher said queue, then it's going to break. And that's used to exit out of this, which could have become an infinite loop. So it's going to break out of the loop. So that's how you quit the program. A, it's going to say if the teacher says they want to add a name to the list, it's going to ask them what is their student's name, and it's just going to add it to the end of the class roster. That's how we use our dot append. If they want to print out the class roster, that's pretty straightforward. We just print it out like that. If they want to remove a name, we ask them, what is the index of the student you want to remove? And again, we have to convert that into an integer. And then we just use our del keyword to go ahead and do that. And we use our C, say like a student has a nickname, so this teacher wants to change the name that they're saved as. we ask them, what is the index of the student's name that you want to change? And then what is the new name you want to replace that with? And it changes that. And if they don't give any valid input, right, they don't give us a Q, A, R, C, or P, Q, A, R, C, or P, then we're just going to say we cannot execute that operation. So let me run this and show you how it works. Oops. I actually have to copy this over into my main.py. This is something I don't like about REPL. You can't like run this file. I can't run class management.py. I have to move this into my main.py in order to be able to run that. So if I run this, it's going to say, what operation would you like to use? Let me open this up a little bit more. So again, it's quit, add, remove, change, or print. Well, I'm going to show you that so far we have 4 items in our class roster. I'm going to do that by just printing that out. So you see, is our class roster printed out. And this is a while true loop, so it's going to come back and it's going to ask me again, what operation would you like to use? Let's say I want to add a student to my list. So what is the sort of mechanic for adding a student? Well, to add a student, it's going to ask me the student's name, and then it's going to append them to the roster. I'm kind of fighting for space, so I'm going to zoom out a little bit so it's easier to see. Hopefully that's not too small. Let me know if that's hard to see. But it's kind of hard to have like my console and then have the code so I can sort of talk about what it's doing. So if I type in A right here, right, teacher choice is equal to A, it's going to ask, what is the student's name? So what is the student's name? It's going to say that to a student name variable. And what does my student's name want to be? Say Jacob, right? So it's going to take that student name and it's going to add it to my class roster. So if I print my class roster now, you see we have John, Susie, Janice, Nitish, and then Jacob. That's been added to my list. Cool. Another operation I can use, so we've talked about adding or appending, so A, and we've used printing. There's a couple more. Now we can look at removing. So let's say one of my students is a gifted student. He's moved on to the next grade early, and I want to remove him from my roster. So what operation would you like to use? I'll put in R. What is the index of the student you want to remove? And let's say that student that's moved on, it's Janice, right? So what is, Janice's index within the scope of my class roster? So Janice is the 3rd item in my class roster, which means she has an index of 2. So I want to remove her. She has an index of 2. So with that, we're using our del keyword. So if I print this now, you'll see that Janice is no longer within my class roster. And then the last thing, or actually there's 2 more things, we have our change. So let's say Jacob. He doesn't like being called Jacob, he likes being called Jake. So what is the index of the student you want to change? So I want to change his name in my books from Jacob to Jake. So what is his index? 0, 1, 2, 3. Well, he has an index of 3, but let's actually use our negative index for this, right? How can we use our negative index? Well, if you remember, we start at our end right here, and we try to count how many times backwards we have to go. So starting all the way here, in order to get to Jacob right here, I only have to move back 1. So Jacob has a negative index of -1. So I put -1 here. And it's going to ask me, what is the student's new name? I want to make it Jake. If I print this out now, you see that Jacob has been changed to Jake. And I could use this negative index. I could use the normal index. But I use the normal index for, removing the student. So I chose to use the negative index just to show how they both do basically the same exact thing. Cool. Last thing to go over is how we quit, right? And this is pretty straightforward. It's just a break. And if you remember in our little section with while loops and our for loops, our break keyword is used to immediately exit a loop. So I press Q here. Oops. If I press Q here, See, it says you have exited the class management system. So what's that done? It's broken out of this entire while loop right here. And now that it's out of that while loop, it's going to default to this message, you have exited the class management system. It's kind of hard to read all this because it's all like packed into this little compact paragraph. But hopefully that can show you guys how we've sort of combined adding, removing, changing, and we also touched upon other things. We use our loops, our break keyword, our comparison operators, our input functions. So as we keep going on and on and on, and we also have our if statements as well. But as we keep going on and on and on, we're sort of combining more and more of what we learn. And this is sort of a culmination of most of the things that we've learned up until this point. So is everybody sort of okay with this? This was an overview of a program. I much rather would have preferred to just code it out with you guys. But if you guys are curious to code this out, go ahead and check out lesson 6 because I do go over that. I think it's like the last part, like in the last half of the lesson. So cool. We've gone over lesson 6, and the last thing I want to do is just do some practice with you guys, some assignments, if you will. Because we didn't get to do that with our recorded lesson, so I want to go ahead and do it now. Let me zoom in. So before I ask you guys these questions, let me just tell you what we're working with here. I have a list. It's got 4 strings in it: Varun, Stephen, Jason, Gloria. And the name of this list is foo, F-O-O, just the name I gave it. So assume that foo is the given list. What would be the output of the following lines of code? So foo dot append Nitish, and I want to print foo. So tell me what would happen if I did my dot append and then I printed foo out again. What would my output look like? Yeah, Luke is correct. Same list with Nitish tacked onto the end, and Maria is also correct. So you have Varun, Stephen, Jason, Gloria, Nitish. Yeah. Awesome job, guys. So that's our first question there. Second question is a little bit easier. It's a freebie. How do we know when we're working with a list? Let me give you a hint. What is like the sort of thing that gives away that I'm looking at a list? Yeah, we have those brackets that tell us, right here. This bracket, it tells us immediately that we're working with a list. Cool. Third question. What would be the output of the following line of code? Print foo, whatever is at the index of 1. What would this give me? Nice job, guys. You guys both got it correct. It is going to give us Stephen. Because why? Again, we're telling Python the index of 1. So this is 0, 1. Nice. And how could you remove the name Jason from the list? Come on, guys. Maybe I'm just laggy. There it is. It's just loaded. But yeah, Luke is correct. We have our del keyword, and then we have foo in our brackets. Let me write what Luke put. He put del foo and in brackets 2. Awesome. Well, how does this work? Python is saying, hey, take my foo list, right? I want to remove Jason, and Jason has an index of 0, 1, 2. So take that item that has an index of 2 in my foo list and just delete it. Awesome job, guys. You have gotten 100% on the assignment for lesson 6. Maria asks, or del foo -2. 1, 2. Yeah, that actually also does work. You could use your negative index with that, and it would do the exact same thing. So Maria's answer was to have this. Let's go over both these things answers. The only thing that's different is really the index, so that's the only thing we have to compare. So uh, Luke chose to use our normal index, that's 0, 1, 2, and that points towards Jason, so that's valid. Maria chose to use her negative index, so we're starting at the back, right? We're going to count back how many times we have to get to Jason. So we have to do 1, 2. So it's 2 jumps backwards, so that's a -2, and that works out just as well. Awesome job, guys. Cool. So we literally just did lesson 6 all over again, but I'm glad it makes sense and it all clicks right now. So it's 1:05. We have about 25 minutes. So I think that's enough time to go over lesson 7. So I have this another REPL open right here, and I'll give you guys another second if you need to create a new REPL. And we can go ahead and continue. We're still working with lists because lists are really just like this whole big thing. And there's a lot of stuff that just goes with it. Luke says, good to reinforce his skills. Yeah, man, it's all about practice, 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 because you can learn something. But if you're not practicing and reinforcing those skills, then they're just going to fade away really, really quickly. And that's why, like, if you get time, um, whenever you should trying to just make some code, right? Just make whatever you want to, get some practice. Take what we've done here in our lessons and remix it, right? Take those ideas and add some originality, add some creativity. And also, you can do some outside research. So, what I mean by that is, let's say you want to um, have some time delays in your code, right? And that's something I'll talk about later. But let's say that's something you want to do. You could always look that up and you can find plenty of resources to explain that to you. Because as programmers, that's such an important thing, being able to search up problems, go through tons and tons of resources, and then being able to pull what you need. Um, Luke asked, can you remind us of that website with project ideas? I forgot the name. Yeah, so that is going to be, I'll just comment it right here, practicepython.org. Let me copy this. I'll just paste that in there. This is practicepython.org. Um, I think it's still being maintained, but basically it has like a bunch of exercises where you can talk about, do you take input from the user? And these are all things that we've covered. And it's actually great because you can actually learn sort of ahead of what we've already done. So list comprehensions, right? This is something that we've talked about with for loops. We haven't talked about our list comprehensions. And think of list comprehensions like a one-liner to do a for loop. Um, I'm not going to get distracted on that, but again, it sort of explains how you can use these things, right? How Fibonacci works, and you can go ahead and see other people's examples. So this is another way to get some practice. There's solutions and stuff like that. So it's definitely worth taking some time to look at. And these exercises are sort of based upon the difficulty, right? So this chili denotes the level of difficulty that the project has. So it's definitely worth taking a look at. Some of these are sort of out of the scope of what we're going to talk about in this lesson. So like this decode a web page, we're not going to be looking at the beautiful soup library until much, much later. But you guys get the gist of what's going on here. You see we have F strings. That's something we've covered. So yeah, I'll leave that. Let's go ahead and continue with lesson 7. I'm actually going to leave this up here. So we're on lesson 7 now. We're still working on lists, guys. So let's create a sample list just for the sake of what we're going to continue with lesson 7. And I'm just going to call it, I want to make it something different this time. Let's make it computer parts. We're just going to make a list of computer parts. You have your monitor, you have your mouse, oops, you have your keyboard, You have your speakers. All right, we'll just keep it short and simple. So now we're going to talk about something called the in keyword. The in keyword. So let's say I want to check what parts I have in my computer parts list, right? And if I don't have this part, I'm going to say I'm missing this part. I'm going to go ahead and code it out, and then I'll rewind and I will explain it. So we're going to say if monitor in computer parts, print you have a monitor. If I run this, it says you have a monitor. So what's going on here? The only thing that should look unfamiliar is this section right here. And what this is it's one of our expressions, right? It's one of those things that can either be true or false. If it's true, then we know that this will print. So what is this saying? This is saying is monitor, right? Is this string monitor in computer parts? So it's literally asking, do I have a monitor in my computer parts list? And if you look at it, monitor, it's in my computer parts list. So this whole thing ends up being true. And since it's true, it's going to end up printing you have a monitor. But in keyword, really, really simple. It's a good way to check to see if a specific item is inside your list. So again, if I do this with speakers, you have a speaker. See, it prints out you have a speaker because speakers, the exact same thing is in my computer parts list. But say I took this S, it's a capital S right now, say I made it a lowercase s, nothing gets printed out. Why? Because this S has to be a capital in order for it to be the exact same thing that's within our computer parts list. So you notice these both spell out speakers, but the difference between them is that one of them has a capital S and the other one has a lowercase s. So that's an important distinction to note. And it's important that when you're checking for things with the in keyword, that they're the exact same thing. So that's our in keyword. It's pretty straightforward. Now we're going to talk about using, well, actually, I should check. Does that make sense how our in keyword is being used? Awesome. And again, you can also use not in, if that makes sense. So you could say, let's say I wanted to look for a cables, right? If cables are not in my computer parts list, print you are missing cables. So this is actually really nice because it reads just like normal English. It says you are missing cables. So we know are not, again, if we remember our truth table, are not switches it. So let's think about how it's working right now. It's first is going to check to see if cables is in computer parts. Do we see cables anywhere within our computer parts list? No. So that's false. But because we have that not, it's going to take that false and it's going to make it true. Since this whole thing will come out to being true, it's going to print you are missing cables. Luke asks, does it only exist within if statements? Well, that's where it's most commonly used. Remember, our in keyword is used sort of for our Boolean expressions, if that makes sense. So if you remember, if I just go ahead and print monitor in computer parts, oops, prints out true. And again, the whole idea of true and false in and of itself is mainly used for control flow. It's mainly used for if statements. So again, this is it existing outside of an if statement, but it's really only used for if statements in the first place. So that's where that in keyword comes into play. So I guess the answer to your question is more like the majority of the time it's used for if statements and else if statements. That is our in keyword, and you can see how you can use not alongside that. So let me comment this out. Now we're going to talk about another way to sort of iterate over a list. What do I mean by that? Well, the first way that we know is through our for loops, right? And we have for I in range. We have the length of computer parts. We do this. We're going to print computer parts I. Right? Everyone is okay with this, right? Because I want to make sure we're all okay with this before we move on with uh, another way of iterating over the list. Okay, awesome. And let's just go over this briefly. Let's start here with our range function. Again, Python starts from our innermost point, it works out. So we're starting with our length of our computer parts. What is the length of this list? 1, 2, 3, 4. So this will end up deducing, or simplifying into 4. This is pretty straightforward. It's going to give us 0, 1, 2, 3. And then we use those indices, right? So 0 will give us monitor. 1 will give us mouse. 2 will give us keyboard. And 3 will give us speakers. It's a really quick overview of how this whole thing works. And I'm using that length function, so I don't have to worry about specifying and counting myself. I can have Python do it for me. So this is one way in which we're able to individually print out the items within my list. What if I wanted to do this in a different way? There's a different way of doing this. It's a little bit more elegant. So what we're going to say is we're going to say for part in computer parts, print part. You'll note that these do the exact same thing. So we said monitor, mouse, keyboard. So this first section belongs to this for loop right here. This second section right here belongs to this for loop right here. So let's talk about this. What am I doing here? Well, actually, let's compare these two, right? Let's see where they're similar and let's see where they're different. Well, the first thing I'm seeing is there is no range function. So that is one of the biggest parts that are different. But I am seeing this for part or for I, right? How we have this for, and then we have this sort of variable that we're using to contain the value of all the items that we're going over, right? And then we're going to print them out. Okay, so what is this first for loop doing? Well, basically, this first for loop is giving us all of these numbers, right? 0, 1, 2, 3, 4. And then we're taking those numbers and we're using them as indices to then get those specific values, right? That should be pretty straightforward. On the other hand, this for loop right here is actually just taking each individual item. We're not generating those numbers and then using those numbers to pull those values, right? We're not generating indices and then using those indices to pull specific values. We are literally pulling those specific values from the start. So what this is doing, right, it's going to say for part in computer parts. And we're going to take this computer parts list and we're going to bring it down so it's just a little easier for us to look at. So this thing is going to run 4 times, right? Because our list is 4 items long. So for part in computer parts. So it's going to take every little part. So we have our monitor, that's one item. We have our mouse, that's another item. We have our keyboard, that's another item. And then our speakers. So it's going to take each of those parts individually, and then it's going to print them out. So that's how we're able to skip having to worry about indices and stuff like that. So does that sort of make kind of sense? And that part variable directly sort of points towards something like this. Can you print it out? Yeah, let's do it. I'm actually going to comment this second for loop out, or sorry, this first one, because we've done this like a couple times now. If I run this, this is what we're running. Again, monitor, mouse, keyboard, sneakers. I'm trying to think of a good analogy to sort of explain this. Let's say I'm trying to collect some items here. Let's say I have a list, right? And it contains my phone, this Lego, a charging brick, and this lens cover, right? These are all 4 items within my list, right? So that's my computer parts list, if you will. For parts, so I'm just kind of, so when the 4 part, it's gonna just take each item from my list. I'm gonna take my Lego man, and it's gonna take that and it's gonna print it out. So that gets printed out. What's the next item on my list? The charging brick. That's the next part. It's gonna print that part out. It's gonna take the next item in my list, camera cover, and it's gonna print that out. And then it's gonna take the next item in my list, my phone, and it's gonna print that out. How is this different from what we were doing before? Well, what we were doing before is we were actually creating numbers, right? 0, 1, 2, 3, 4, or 0, 1, 2, 3. And then we're using those numbers to then pull those values out. So it's sort of like there was an extra step with that. So hopefully, maybe that might make a little bit more sense. Maybe my example, my real life example, wasn't the best or the most thought out, but hopefully it could give you guys a little bit more clarity with what we're doing here. So let's see, does that make a little bit more sense what we're doing here? Yes, it prints them out individually. You're getting 1 by 1. And it prints them out directly. You're pulling that monitor, you're pulling it directly. You're not creating a number and then using this number, right? Because that's what we're doing right here. For I in range, well, that generates a series of numbers. And then we're using this number as an index to pull the value. However, with this, we're pulling that value directly. I'm going to go ahead, get rid of this in keyword stuff. Now let's try something a little bit different. We're going to work with this, but we're going to use a different example just because we want to see how we can work with, sort of interact with our specific values more directly. I'm going to clear this out, and we're just going to create a series. We're going to call it student grades. Student grades, okay? And we'll just have a bunch of numbers from 0 to 100. We'll say one student got 100, someone got an 86, someone got a 92, someone got an 82, someone got a 70, someone got a 79. These are just a bunch of sample values, right? Again, this is a data container, and it's containing all these integers. So student grades. Again, what would I do if I wanted to print them out individually? So I'd say for grade in student grades. And again, this grade can be whatever you want it to be. But I like to call it grade because it just makes sense within the context of what we're doing, because we're printing out each of these grades individually. In student grades, we're going to print that grade out. So what are we doing? Hey, we have this student grades list. Take each of these grades individually. Right? So take that 100, print it out. Take that 86, print it out. Take that 92, print it out. Take the 82, print it out. So just like that, it's going to print all of these out. And with this method, there's no need for me to specify a range or a length or to use indexing. It's all very straightforward. So let's go ahead. What are we going to do? Let's take our student grades and let's take these integers and let's manipulate them in some way. Let's subtract, or let's say everyone did really, really good and we're going to give them 5 bonus points, right? So we're going to take that grade and we're going to add 5 to it. We're going to take our grade. We're going to say, we're going to call it bonus grade. We're going to create a variable called bonus grade. We're going to take this grade that we get, so in like 100, 86, 92, say it's our grade, and we're going to add 5 to it. Print that out now. We get 105, 91, 92, 87, 75, 84. So we're taking all these values individually, right? We're adding 5 to them, saving that to our bonus grade variable, and then printing it out. So let's create a sort of print statement that shows what our grade was before and then what our grade is with our bonus applied. We're going to say print. You originally got a placeholder, period. With the bonus, you now have a placeholder. Our F string in. So you originally got a grade. Well, with the bonus, you now have a bonus grade. Move this over. We print this. It says you originally got 100, so that's his first value right here. With the bonus, you now have a 105, so that's us adding 5 to it. Second thing, you have an 86. With the bonus, you have a 91. 92, right? That's his value right here. With the bonus, you have a 97. 82 with a bonus 87. So it sort of works like that. That's how we're able to pull those values specifically. So that's how we're able to use this different sort of way of using our for loops with our list. Is everyone okay with that? And again, we're just learning right now. With practice, all of these things will come much, much easier. And actually, we have about 4 minutes left. So let's just go over one last thing really, really quickly. I'm going to get rid of this. The last thing we're going to talk about, it's not really that important, but it's always something good to have under your belt. It's called a tuple. A tuple. Tuple. Think of this as a list, but you can't change it. A list, but you can't change it. So let's create a list and a tuple side by side. They'll have the same exact thing, and I'll show you how it works. And we'll just use the student roster thing one more time. Student roster is equal to, call it Varun and David. We'll just have 2 names for now. Then we'll create another variable called student roster tuple, because his first thing was a list. We'll call it student roster list. How is a tuple different from a list? Well, the first difference is that you can't change it. So it's something called, it's immutable. Immutable. Im means not. Mutable means able to change. So not able to change. Immutable. Another difference is how you write a tuple. So a tuple actually goes within parentheses. Then you have Varun, and you have David. So very similar, except one has brackets, the other one has parentheses. And if we print this out, print student roster list, and then print student roster tuple. If I run this, both work, right? One of them gives me a list, the other one gives me a tuple, and I can tell the difference based on one having brackets and the other one having parentheses. Cool. Now let's say I wanted to add a name to my list or in my tuple, right? So I'm going to student roster append. We're going to add John. Okay, let's print this out. And we see, oops, student roster list append. That works perfectly fine. So let me try this with my tuple. So student roster tuple append John, and then print out the student roster tuple. And this error. Tuple object has no attribute append. What is it saying? It's saying, you know how I talked about append is something that's specific to a list or a specific data type, like that's how a method works. That tuple isn't able to, it doesn't have the ability to append things to it. You can't change things in a tuple, or you can't add things in a tuple. Okay, so we can't add things. What about if we try deleting things? So let me clear this. Let me just delete the first item in my list in my tuple. Okay. I'm going to get rid of that Varun. And then we're going to delete student roster tuple with 0 in there. And we're going to print out the tuple after we do the thing. We're going to print out the list after we do the thing. If we run this, you see we have our first two things. That's where we originally start, right? We can delete the first item from our list, right? And it prints out just fine. When we try to do it from our tuple, it says, hey, tuple arrow doesn't support item deletion. You can't delete items from a tuple. Why? Because it's immutable. It's not able to change after you make it. And I might be wondering, well, why would I have them in the first place, right? Wouldn't a list be much better to use? Well, main reason why tuples are used, let's say you have like coordinates, right? Coordinates for a location, chords. And these are things that don't change, like a location's coordinates, right? It's latitude and it's longitude. A tuple might be used because the fact that a tuple can't be changed makes it a little bit faster to work with. And that's a sort of a weird thing to imagine, but tuples do have their usage. So if you're ever working with data like coordinates, right? Things that don't have to necessarily be changed, then a tuple is the way to go. And again, it's one of those smaller things that you won't always use, but it's always good to have under your belt. And they work very similar to our lists. So that is an hour and 30 minutes right there. That's our first lesson in the month of July. So can you call individual items from a tuple? Yeah. So yeah, let me just stick with this right here. Let's say I wanted to print out like the first item in my chord tuple. Print chord 0. So it works the same way, except for like those specific adding, deleting, and changing things. Anyway, a great lesson. This is the first lesson in the month of July. And before we go, I actually wanted to get some input from you guys about what I've been considering doing with the lessons right now. What I want to do is do all of the lessons on Saturdays and Sundays, right? So it's on the weekends, it's easier for everyone to access. What I wanted to do was have an hour and 30-minute long lesson on Saturdays, and then on Sundays have a brief 30-minute sort of review lesson where we just go over everything we did in the previous lesson just to make sure that it works, or do a quick project, things like that. So what do you guys think about that? Would you guys rather have a 2-hour lesson on Saturdays, or are you open to the idea of having a 1 hour and 30-minute lesson on Saturday and then a 30-minute quick brief review project building lesson on Sundays? Because whatever works, right? So I just want to hear your input with that before we go ahead and call it for today. Awesome. So I'm seeing 1 hour 30 on Saturday and 30 minutes on Sunday. I like the Sunday idea. It makes it so we can spend less time reviewing old stuff at the beginning of the Saturday lessons. Yeah, I do agree. That review did take a little bit longer than I would have liked it to. So let's go ahead and go by that. I'm actually going to open up a 30-minute lesson for tomorrow. And we'll do it at the same time, 12 to 12:30 Eastern Standard Time. And so, yeah, I'll see you guys tomorrow. Maybe we'll do a little bit of a project with what we build. So, yeah, thank you for your input, and thank you for a great class, everyone. Take care of yourself. And so I will see you tomorrow at 12 o'clock Eastern Standard Time for a review lesson. So take care, be safe, practice. Make sure you practice. And again, practicepython.org, that is the site to go to.